Okay, so we have been looking at descriptions logics. Which some people also call as terminological logics or logics of noun phrases. And just to do a quick recap, we have been looking at a language which we can give a name, we will just call it DL, and it has got these operators or concept forming operators, which is all, fills, exist, and. So, these are the only 4 operators that we allow in this language to form new concepts from atomic concepts or from other concepts essentially. So, the major advantage of this language was that you could use you could answer the question whether a concept D is subsumed by another concept E, you could use this algorithm called structure matching. And this we saw was polynomial in the length of in expression length. So, you did not have to search the entire knowledge base to try to establish this fact essentially. Remember that when we said the concept D is subsumed by the concept E, it is equivalent to saying all D's are E essentially. So, if you look at first order logic, you have written a statement like for all x dx imply Ex, then that would be an equivalent concept. But there to establish something we had to search for formulas and do resolution or do forward chaining or backward chaining and that kind of stuff. But here, because of the fact that we are using this description logics, we can describe these concepts and then we can just use structure matching to answer this question whether D is subsumed by E or not. And then we had seen after this that once we can answer this question, then we can construct a taxonomy right, use this to of concepts, in which concepts automatically fall into the rightful place based on the descriptions that they have essentially. So, we have seen all those algorithms here. Today, we want to see what is the restriction of this particular language essentially. So, this language it is a very simple language, it allows you to use these 4 constructs, all role fillers come from a class D, or a role filler is filled by a constant C, or there exists at least some n role fillers, or conjunction of any of these descriptions by using the AND thing essentially. We cannot say, so this is not expressive enough. So, we cannot say things like every class has at least one student, or you cannot say that for example, in IIT Madras research students are, as we call them, regular or external. Of course, they can be project students also, but that does not matter. Or you cannot say my or let me use the word superior. My superior is also my superior. And we are talking about the relationship where somebody is the boss of somebody else essentially, or we cannot say that the role mother is a sub role of role parent. We can only talk about subsumption of concepts, we cannot talk about subsumption of roles essentially. So, we can't say that the mother is a type of parent or father is type of parent and this kind of a thing. So, what we will do today is to first try to extend this language with maybe some extra concepts and then demonstrate that by increasing this expressivity we lose out on structure matching essentially. So, the structure matching, which is a nice simple algorithm, will not be applicable for more expressive languages. And then later on we will move towards more modern languages which actually abandon structure matching altogether and move towards tableau based proof systems, which we have seen when we are looking at propositional logics. So, we will see them for another description logic called ALC. But first let us try to talk about extending this language essentially. So, let us say we have this language DL and then we add one more concept forming operator and we call it at most. So, this is a little bit like exist in R, except that exist was talking about at least that many role fillers. What if we also add at most that many role fillers? What happens to our language essentially? So, the first thing is that you can have contradictions. So, for example, you can say and at most 3 role fillers and exists 4 role fillers. It is a perfectly, it would be a perfectly well formed statement in our language, but it is a meaningless statement because as you can see it basically stands for the empty concept or empty set essentially. You cannot say that you have at most 3 and at most 4 children, for example. So, at most 3 children and at least 4 children. So, obviously, it does not represent any tangible set essentially, but even if it did. So, the first thing is that it allows you to make contradictory statements and that is a issue with many knowledge representation exercise, that if you are building a knowledge based system and you want to create a knowledge representation system, you want it to be consistent, you want it to be devoid of contradictions essentially. And if the language can help you avoid contradictions, or if you can write efficient algorithms which can check for consistency, then it is a good language essentially. So, here you can say this, but what is really more difficult for us is that if we add this extra constructor, structure matching no longer applies. So, we can show that by an example. So, let us say that we have a description all and so, C is a role filler and at most one role filler. So, there is a role R for which C is a filler, and we are also saying that this is a set of concepts in which there is at most one role filler essentially. So, it is a kind of a functional language in that sense. Then we say that fills another role called S, the same concept, the same individual C, and then we also say that all S are D. So, R and S are two different role fillers. We for one role S we are saying that C fills that role, let us say S stands for student or something, and then D let us say stands for bright, and then we say all students are bright essentially. Then R could be another role filler, and we are saying that C also fills that role R, and this role and only one element can fill this role R. So, this is a concept. Now, if you look at this concept, all are D. What is the relation between these two concepts? You can see that this concept which uses at most should be subsumed by all R D. Why is that? Because we can establish a connection between R, between C. So, C is a D, right. Why? Because all S's are D and C fills that role S essentially. So, once we know that C is a D, we also know that C fills R here, and we know that C is the only element which fills R. Therefore, this concept describes a concept in which all R fillers are from the class D essentially. So, which is a concept on the top essentially. So, this concept below should be subsumed by the concept on the top. Or should I should say should subsume this concept essentially. So, the concept on the top should subsume this concept, but you can see that there is nothing you can do in structure matching to try and use structure matching to try and establish this this subsumption relation, which means that structure matching has gone out of our repertoire of using this language essentially. So, we have to do something else essentially. So, all we did was that we extended the language by saying that let us have one more concept forming operator called at most, and we can see from this example that we can have situations like this, where we can define concepts which are clearly subsumed by some other concepts, but structure matching will not help us to decide that essentially. Then we can have other concept forming operators. So, let us look at a couple of them, and then we will try to look at a new language altogether, or a whole family of languages actually. What are the kind of things that we would like to use essentially? So, for example, you might say you want to define days of the week. So, you want to define this as a concept, and you could use something like this, one of Monday, Tuesday up to Sunday. These are the kind of concepts that we may want to define, days of the week, days of the month, and so on and so forth. This language of course does not allow us to do this sort of a thing essentially. Then another thing that we had mentioned in the earlier is that you cannot define the notion of an aunt using the given language. So, you cannot define with, so these are not enough. So, what is an aunt? So, an aunt is someone who must have a sibling, right. So, we can say for example, exists one sibling, that is fine, but we also want at least one of the siblings to be a parent essentially, only then you qualify to be an aunt. Of course, you have to be female. So, and but what after this? How do you say that the sibling is should also be a parent? This language does not allow us to do that. It does allow us to say that all siblings are parent, but we are not after that concept. We want to define that there must be at least one sibling which is a parent essentially. So, one way or a couple of ways that we can try to define this is again to extend the language. So, let us try extending it by instead of exist, what if we define D exists, another concept forming operator, and you say that you have n role fillers from the class D. So, we have made it 3 arguments now. So, supposing we add this operator which says that you can say that a class of people who have at least n role fillers which come from the class D essentially. So, then you could say that you have at least one sibling who is a parent essentially. So, then but this is not part of our language, we are trying to see whether it would help us to define the language essentially. Or we could say we could try to extend this fills essentially. So, as of now fills says that fills role constant, we could try to say let us call it D fills role from a class D essentially. So, instead of saying that an individual is related to this concept, we are saying that a class is related to a concept. So, then of course, you could say fills sibling parent and then we are done essentially, but these are not in the given language that we are working with essentially. So, supposing we had this, then we could define an aunt by and female exists one sibling and D fills sibling parent, or we could say and female simply the one that we just said, D exists one So, let us say this is a definition for aunt, or this is a definition for aunt in our new language. What about if I have another concept and female who has at least one sibling and all siblings are parents. Let us call this, for want of a better name, auntie. Now, again you can see. So, what is the concept in the red? It says the set of all women who have at least one sibling and all whose siblings are parents essentially. Whereas, the concepts below are saying that who have at least one sibling who is a parent essentially. So, in the concept below allows for siblings who are not parents, but the concept above does not allow for siblings who are not parents essentially. But nevertheless, the concept on the top should subsume the concept below essentially, because if you are an aunt who has 3 siblings and all of whom who are parents, then you subsume a concept where you are an aunt who has at least one sibling who is a parent essentially. Your other siblings may not be parents essentially. So, this should subsume. But it does not, because we cannot use structure matching to decide this subsumption relationship. Even instead of exists, if I had used d exist or something like that, it would not work essentially. So, let us try one more operator which has been suggested by Brackman and Levesque, and this is called rest R. Role class. This restricts a role to having fillers of a class essentially. So, the difference between what we are doing now and what we tried to do earlier is that now we are trying to define a new role. We are trying to talk about a subset of a role essentially. So, we should be able to say, for example, that what does this say? This says that there is a group of or class of people whose daughters are all rich essentially. Which is different from saying something like all child and which, as you can see, they are different concepts. So, this of course, the second concept is in our given language, this is in DL, this is not DL, this is with the extension this thing. What is this saying? The second concept is saying that all children are female and rich, whereas this is not what we wanted to say. We wanted to say that all daughters are rich. So, this restrict R is restricting the role essentially. So, instead of saying that talking about child, we are talking about all children who are female, and then we are treating this as a new role. and now we can say that all female children are rich essentially. So, using this again we can express our aunt relation. So, an aunt is a female who has at least one sibling who is a parent. We have already restricted the sibling to belong to the class parent, and therefore, we can say we can define an aunt essentially. But again I will leave it to you to see that this concept of this woman who has all the siblings who are parents is a super class of this concept, and this will we are not able to establish subsumption essentially. So, let me end with another example. So, let us say we have this concept all so, we are restricting the friend relation to male doctors. So, now we are not talking about all friends, we are talking about all friends who are male doctors, and then we say that they have some property which is let us say and tall and rich. So, we can express this using the new restrict operator. We can also define another concept where all where you first talk about a certain class of friends whose all male friends are tall bachelors and whose all doctor friends are rich surgeons. So, the concept on the top is talking about all the set of people whose male doctor friends are tall and rich. The second set, the one below, says the set of people all whose male friends are tall and bachelors and all whose doctor friends are rich and surgeons. So, they can be a separate set, we are talking about males separately and doctors separately essentially. But as you can see, we have said that with male we have associated the property of being tall, and with doctor we have associated the property of being rich, and these are the two properties that we are interested in with male doctors essentially. So, obviously, the set below should be subsumed by the set the class below, but as you can see that there is no way you can try to improvise with structure matching to do this essentially. So, now this is one of the reasons that people sort of moved on to higher more expressive languages, and this happened because of the advent of the semantic web, where you want to describe domains where programs can talk to other domains and so on, and you want to be able to say all more expressive things than is allowed in this language. So, in the process what has happened is that we have had to abandon structure matching, and there is a whole host of web languages. So, we have a language called OWL. You must have heard OWL is an acronym for Web Ontology Language. So, we have OWL full, we have OWL DL, where DL stands for description logic. We have OWL light, and more modern standards are coming out. So, we have OWL 2 full and OWL 2, we have DL, we have EL, we have some RL and so on. So, there is a whole host of languages which have come, each with different expressivity and each with different computational complexity essentially. So, in fact, these two languages are not based on DL and they are undecidable. Whereas, the rest of the languages are a decidable subset eventually, and they also have their gradation of how much you can express in that essentially. Okay. So, in the next couple of classes we will look at one of these new languages, it is called ALC. We will look at the language, then we will see how reasoning can be done using the tableau method that we had looked at in the case of propositional logic, and we will look at it again in the case of description logics. Can be used to arrive at the conclusions that we want to arrive at. So, the major conclusions that we want to ask, questions, the kind of questions we want to ask are: is a knowledge base satisfiable, is it unsatisfiable, is a concept subsumed by another concept, does an individual belong to a certain concept. All these concepts we will look at in the context of a new language, which we will see in the next class.